Hi folks, today we're going to look at tangent and chord properties of circles. So here you can see it says you can use the properties of tangents and chords within circles to solve geometric problems. A tangent to a circle is a straight line that intersects the circle at only one point. And the key thing we need to know about the tangent here is a tangent to a circle is perpendicular to the radius of the circle at the point of intersection, so it makes a right angle. A chord is a line segment that joins 2 points on the circumference of a circle, and it says the perpendicular bisector of a chord will go through the centre of the circle. I think the diagram explains that really quite nicely. Okay, I'll just give you a second just to absorb that. And then I'd like us to think about this question. Now the question says, the points P and Q lie on a circle with centre C as shown in the diagram. The point P has coordinates -7, -1, and the point Q has coordinates 3, -5. M is the midpoint of the line segment PQ, and the line L passes through the points M and C. Find an equation for L. Right, okay. So here I've got the diagram going on, and I might just think about drawing myself a little triangle P and Q. That's -7, -1. That's 3, -5. And I often like to put down what this point here would be, which would be -7, -5. So you can see that to go from P to Q, I've gone -4, and to go from, so I've gone -4 down, and to go in this direction, I've gone up 10. So the gradient here is -4 over 10, which is -2/5. Now, if I want to find out M, which is here, that's halfway along there and halfway along there. So we're going to do, I could do, let's do it the traditional way. So I've got, looking at the x's, I've got -7, add 3 divided by 2, and I've got -1 add -5 divided by 2. So -7 plus 3 is -4, so that's -2. When I half it, they come to -3. Sorry, -6 divided by 2 is -3. So the midpoint is -2, -3. So thinking about the line that goes through them, so line L has gradient, and we're going to think about, because it's at right angles, that was the key thing about the chord, the perpendicular bisector going through the centre of the circle, has a gradient of 5 over 2. The negative reciprocal, remembering that they have to times together to give -1. So we're going to use the formula M equals y minus y1 over x minus x1. We know it goes through the centre of the circle, so I've got 5 over 2. Well, actually, we know it goes through the point that we've just been given, which is -2, -3. So I've got y plus 3 and x plus 2. So if I bring that just to here, I've got 5 lots of x minus x plus 2 is equal to 2 lots of y plus 3. So 5x plus 10 is equal to 2y plus 6. So I might say that 5x plus 4 is equal to 2y. So y is equal to 5 over 2x plus 2. And I'm going to leave it like that in that format. Now, the second part of the question says, given that the y coordinate of C is 8, it's negative 8, show the x coordinate of C is minus 4. So I've got y equals 5 over 2 x plus 2. So minus 8 is equal to 5 over 2 x plus 2. So if I times everything through by 2 there, I get minus 16 is equal to 5x plus 4. Take 4 from both sides, you get 5x is equal to minus 20. Divide both sides by 5, I get x is equal to minus 4. And that was what he was asking. The final part of the question says, find the equation of the circle. So we know that the centre of the circle is minus 4 minus 8. And that's going to give us a large part of our equation for the circle. The thing that we do need to find is the distance of any point from C. In other words, the radius. So if I look at point Q, Q is 3 minus 5, and C is minus 4 minus 8. I can see that that my change in x there is 7. My change in y is 3. So my radius, if I use Pythagoras, I'm going to use r is equal to 7 squared plus 3 squared, which is the square root of 58. So putting that all together for my equation of my circle, I get x, and it's going to be minus, and then minus 4, so that's plus 4 squared, plus y, and minus 8, so that's plus 8 squared is equal to root 58 squared, so that's 58. And that should be my final answer. And it is. So just looking back, we used the chord, perpendicular bisector of the chord going through the centre of the circle here. Some things that we needed to do. So we needed to find the gradient of the chord, the midpoint of the chord, and putting those two bits together, we could work out the perpendicular bisector. Gradient of the perpendicular bisector was the negative reciprocal. And we use this formula here, knowing it went through the midpoint there, and that gave us our formula. We used the formula knowing one of the values of the centre to find the other one, and then we worked out the radius using Pythagoras, and we put it all together using the formula of the circle that we know. So quite involved questions. Notice the space that I've used and all the different things that I've used to work it out. Please don't be afraid to use space, because it's the way to guarantee that your thinking's on the right lines. The biggest error you'll make is by trying to do too much in too small a space. Okay, thank you.